Welcome to this explainer. Okay, I am absolutely thrilled to have you here today because, well, we're embarking on a pretty fascinating journey. We are going to unpack the actual nuts and bolts architecture of modern intelligent software systems. If you've ever found yourself wondering how cutting-edge applications seem to just seamlessly extract messy real-world data, secure it flawlessly, and then store it with perfect structural integrity, you are in exactly the right place. We're going to break down the blueprint for these modern automated systems step by step. So here is our roadmap for today. We're going to synthesize three distinct technological pillars into one cohesive blueprint for building scalable apps. We'll start with building modern automated systems, then dive into AI-powered data extraction, move right along to securing access with JSON web tokens, explore smart relational database management, and finally look at the real-world impact of all this automation. All right, let's kick things off with Section 1, Building Modern Automated Systems, from rigid to smart architecture. To really understand why we desperately need a new blueprint, we kind of have to look at the massive problem with legacy systems. I mean, for years, businesses have been literally bleeding time dealing with rigid databases and completely unpredictable data. Anyone who has ever tried to manually process invoices knows the absolute nightmare of a vendor suddenly deciding to move their total due box half an inch to the left, right? To solve this chaos, modern systems require three foundational pillars. Think of it like an anatomy lesson for software. We're essentially building our conceptual application today using three main components: the brain for intelligent processing of incoming data, the bouncer for secure, stateless access, and the vault for robust, intelligently structured storage. When these three work in perfect harmony, that's when you achieve true automation. Which brings us nicely to Section 2, AI-powered data extraction. Let's take a look at the brain. So look at the stark contrast between our past and present here. Traditional optical character recognition, or OCR, is highly template dependent, like we just talked about. If that invoice layout changes even a fraction, the whole rule-based system just completely breaks down. But today we use large language models and deep learning. These modern AI tools do not rely on rigid templates. Instead, they use semantic comprehension. They actually understand that phrases like amount due, total payable, and please pay this before we sue you basically mean the exact same thing. And that makes them incredibly context-sensitive and adaptable to totally unpredictable document layouts. And following a document through this hybrid workflow really reveals why it's so powerful. You can trace how a scanned image enters the system and gets intelligently routed. First, it goes through image preprocessing to, clean things up, and then into an OCR extraction phase. But it doesn't stop there. It branches out. It uses deep learning table detection to understand really complex grid layouts, while simultaneously using LLM processing to pull out specific entities and map patterns. It's essentially an entire symphony of different AI models working perfectly together to produce a clean, structured output. And the result? By using this multi-layered hybrid architecture, systems are now achieving a staggering 95% character-level accuracy. Think about that. That's 95% precision, even when processing highly diverse and super messy invoice templates. This level of exactness is exactly what finally makes true hands-off automation a reality. Let's quickly break down the specific tech stack that's powering this process, because it's not just one magic AI tool doing all the heavy lifting. For text extraction, modern systems are leaning on advanced models like DOCTR and transformer-based Trocare. For field detection, literally drawing those little bounding boxes around crucial info, they use YOLO 5. To parse out complex line items hidden in grids, they deploy TableNet. And finally, for semantic entity recognition, understanding the actual, real-world meaning of the text, they pipe the data through advanced models like the Gemini API. As you can see, it's an ensemble of highly trained specialists. Moving on to Section 3, Securing Access with JWT. It's time to meet the bouncer. Okay, so now that our brain has extracted all this highly accurate, incredibly sensitive financial data, we absolutely must protect it via our API. Let's clearly define the tool for the job. A JSON Web Token, or JWT, is a secure, URL-safe means of representing verified claims transferred between two parties. In the context of modern web frameworks like FastAPI, for example, JWT is the absolute gold standard for verifying user identity statelessly. The server doesn't need to maintain a massive clunky session database. The token itself cryptographically proves the user is exactly who they claim to be. And here is the exact authentication loop, step by step. First, a user logs in or registers. Second, and this is absolutely vital, their plain text password is never stored. Never. It is instantly hashed using algorithms like bcrypt, which honestly saves us all from those dreaded plain text password leaks. Third, upon verifying the credentials, the server generates and signs the JWT, handing it right back to the client. And step 4, the client includes that token in the header of every single subsequent request to access protected API routes. It's fast, it's secure, and it is infinitely scalable. All right, section 4, smart relational database management. Let's open up the vault. So we've extracted the data, we've secured the gates. Now to build a modern vault for where this data actually lives, we use an ORM, or Object Relational Mapping tool. Specifically, we're looking at SQL Model today. SQL Model is this brilliant library that seamlessly connects Python objects to SQL database tables. It combines the data validation power of Pydantic with the hardcore database interaction strength of SQL Alchemy. This makes database interactions in frameworks like FastAPI incredibly smooth and completely type-safe. Now, what's really interesting here is that the key to a highly secure vault is the architectural separation of concerns. In SQL Model, we don't just use one giant catch-all model. We strictly separate table models from data models. Table models are mapped directly to the database engine, meaning they hold absolutely everything, including internal backend IDs and secret hashed passwords. But data models, those are what we expose to the client for reading or creating data. By using inheritance, we ensure that backend IDs and secret data are literally never accidentally exposed to the public API. The core identity of our system's data remains perfectly shielded behind the scenes. To build a robust production-ready schema, you really need to follow these core best practices. First, use a base class for shared fields to keep your code perfectly dry. Don't repeat yourself. Second, create specific update models where fields are optional, so clients can smoothly patch just one piece of data at a time without breaking things. Third, and actually, we just touched on this, but it bears repeating, absolutely never return passwords or internal IDs to your public API, unless you want to make the news for all the wrong reasons. And finally, utilize session dependencies in your API routes to guarantee thread safety when you're writing to the database. Which brings us to our final stop, Section 5, the impact of automation and real-world results. We have the brain, the bouncer, and the vault. When an enterprise implements this entire end-to-end system using hybrid AI to extract unstructured data, securing it flawlessly via JWT, and storing it seamlessly with an ORM like SQL Model, it results in a massive 80% reduction in manual human intervention. 80%! Think about the sheer amount of human capital, energy, and creativity freed up by that single metric alone. And hey, if you want to look at pure velocity, just consider the total collapse in processing time. Manual processing of a complex document takes roughly 120 seconds. Traditional OCR, that cuts it in half to about 60 seconds. But this proposed modern system we've been talking about, it drops processing time down to a mere 9 seconds. It fundamentally transforms the scalability of enterprise workflows, turning sluggish manual operations into these near instantaneous digital pipelines. I want to conclude this explainer with a somewhat provocative question for you to take away. We've seen how effectively this blueprint works today, but as these AI systems inevitably evolve into fully autonomous financial agents capable of complex problem solving, what part of your daily workflow will become obsolete next? Something to chew on. Thank you so much for joining me for this deep dive into modern automated architecture. Stay curious and keep learning.